Hey, this is the video for 6.2, Global Energy Consumption. So go ahead and check out the overview and set up your guided notes. So a general rule of thumb is that if you have a higher standard of living, the energy use will increase. So the wealthier a country is, the more energy is used. And this is true in America. We use actually 5 times on average, 5 times more energy than the global average. That's a lot. And this is because we have a readily available energy. We are a large country. We have different energy resources. We also have, that makes it relatively cheap, so everybody can afford it, or not everybody, but most can afford it. And also we have the government regulating it. So the government may provide subsidies for different types of energy to bring the prices down. Now, energy use per capita, globally speaking, this would be high amounts of energy use. You see United States per capita means per person. Canada actually uses more, but Canada has a much, much, much smaller population than the entire United States. If you also look at the Human Development Index, this is basically the standard of living for each country. This is from a website called Our World in Data, and it's an amazing website, especially for energy. If you like maps, I would check out Our World in Data. It gives you maps and tables, and it's really awesome. We'll probably use some of it in class. But if you notice, it kind of directly correlates. Like, you see these areas where they have low energy use per capita, they have a very low development index. So this is something that is correlated. Now, globally, this is the amount of energy or electricity that is produced from each of these sources. If you notice, most of the electricity globally comes from coal, and then we have gas and hydropower. So if you look down here, these are all of them. You can also, again, consult Our World in Data and look at some of these graphs. Now, this is literally just energy that is produced. If we go over here, this is energy that is consumed. So if you notice, we have more energy coming from oil. And this is because oil is made into gasoline, and gasoline powers our automobiles. So a lot of the energy that is consumed is for transportation. It's very interesting. This is from 2022. But if you look, there was a dip right here. And if you notice, they all kind of dipped. So we consumed less energy. And the reason we consumed less energy is because of the COVID lockdown. Basically, there was a lot less driving during this time, a lot less transportation, less energy use as well. So let's look at a question based on this information. It says, based on an annual consumption of 52,970 terawatt hours, calculate the oil consumption per person per day in kilowatt hours. So what we're going to need to do is we're going to figure out our given and our unknown. We also are going to need to convert terawatts into kilowatts. And it doesn't matter about this hour. This is just a unit. Remember, we're just converting the first unit. We're going from tera to kilo. So our factors are here. We got 52,970 terawatts is our given. And what we need to do is figure out per person, per day in kilowatt hours. So we have 52,970 terawatt hours per planet per year. Now, this is because it's a global consumption. If you don't put per planet, I mean, that's not the end of the world. There's different ways that you can do this, and I'll explain it after we're done. But again, you definitely need to start out with the terawatt hours. Now what we're going to do is we have our planet, or globally, so our planet has 8.1 billion people, and if you notice, I put this in red. This is an abbreviation for people per person. That is our final unit, so we are done as far as per person. Now we want to go ahead and cancel out our terawatt hours and our years. So let's start by canceling out our year. And 1 year is 365 days. And now notice that we have our final unknown is per day. Per day and per person, they're both on the bottom. That's why they are per person, per day. So we are done with both of these unknowns. Now what we want to do is cancel everything else out and get kilowatt hours. So we got terawatt hours. We need to convert terawatt hours. So 1 terawatt hour is 1,000 gigawatt hours. And then 1 gigawatt hour is 1,000 megawatt hours. And 1 megawatt hour is 1,000 kilowatt hours. Now, if you happen to know that this is a factor of a billion, I doubt that you did. So I would take it step by step because you just don't want to make those mistakes. Now what we want to do is cancel our like units. So we got to cancel the terawatt hours, cancel out our planet, cancel out the year, cancel out gigawatt hours, and cancel out megawatt hours. We are only left with our unknowns. When we multiply, again, we're multiplying across. So 52,970 times 1,000 times 1,000 times 1,000 divided by 8.1 billion divided by 365 equals 17.9 kilowatt hours per person per day. Now, the other way that you could do this is you could also just convert terawatt hours directly into kilowatt hours by, skipping this part, and you can go terawatt hours and convert the other parts. And then at the end, divide it by 8.1 billion people, which would bring it to per person, divided by 365 days, which would bring it per day. I showed you this method because this is the way that I am going to be doing it every time. But there are different ways as long as you show your work, and you have to label and show every single unit. Here's another way of seeing this exact same graph. Now I just want to point out that this is the other graph that I showed you before, and this is another way of viewing it. And this is showing you all of the energy forms just kind of stacked on top of each other. So the way that this works is, if you notice, this is the amount of coal that is used. That looks like it's about 45,000. And when we take the amount of coal here, it starts here and it ends here. If we bring that number over here, that also shows that it's roughly 45,000. So this is just another way of viewing this. Now oil is slightly higher. If you notice, this is the same scale. This is 45,000. And it shows that oil is a little bit more than coal, which is appropriate because up here, oil is also more than coal. Okay, so what can the government do? So things that the government can do is they can mandate the percent of energy sources. Like, for example, the United States has mandated that 25% of our energy should be renewable by 2025. European countries are taking a much stronger approach, and they're definitely more sustainable, I would say, than the United States. They can also increase taxes on fuels in order to discourage the use. You can increase the gas taxes. They can also offer rebates or any sort of economic perks for using renewable energy sources. Like if you get solar energy, for example, if you put a solar panel on your roof of your house, you can get a tax break. If you switch to wind energy, you can get different rebates as well. Things that the government cannot do is they cannot raise or lower gas prices. This is just from capitalism, supply and demand. So this cannot be done, but if the government wants to discourage use, they definitely could increase taxes. So what I would like you to do is respond to this check for understanding. And to practice for the FRQ, I want you to explain why the United States is a global leader in total energy use. I hope that this video was informative. I thank you for your attention, and I will see you soon.